Politics can determine the destination, but it cannot negotiate with physics. When uncomfortable technical evidence emerges inside a nationally critical system, the important question is not which side wins the headline. It's whether the institution can produce an answer that engineers and the public can trust. Hello, I'm Jason Broderick Pearce, and welcome to Engineering Resilience. Now, in my work, most of the politics happens somewhere else. I would say, thankfully. It happens in underwriting rooms, board meetings, budget meetings, conversations behind the scenes. But my job's generally much simpler, thankfully. I inspect the system. I follow the evidence. I ask what could fail and what protects against that failure, and whether those protections will actually perform when required. Now, in that sense, I get to just be an engineer. So, part 3 of Engineering Resilience this week examines what happens when engineering risk becomes political. And I'm using the developing controversy surrounding Britain's national energy system operator as my basis for this talk. Now, during the week beginning the 22nd of June 2026, extreme temperatures created significant operational pressure across Britain's electricity system. And on the 23rd of June, NESO issued an emergency instruction and sought emergency assistance through interconnectors with France and the Netherlands. Now, electricity margin notices followed again on the 24th and the 26th of June. And the system frequency is recorded as falling to 49.66 Hz. Now, that's outside NESO's normal operating range of 49.8 to 50.2 Hz, but remained above the statutory lower limit of 49.5. And no customers lost supply. So those facts require balance. The frequency excursion demonstrates the system experienced significant stress. It doesn't by itself prove that Britain was moments away from a national blackout. But the fact that the lights remained on doesn't prove that every operating standard, security requirement, and decision process worked exactly as intended. So NESO's position is that the system remained secure throughout an exceptionally challenging period. However, preliminary internal documents disclosed through subsequent reporting recorded constraint breaches and stated that system security had in fact been compromised. And whistleblowers then made more serious allegations regarding operational record keeping, preservation of audit trails, and possible management or communications influence over operational decisions. Now, I should say NESO disputes those allegations, and this distinction is essential because at the time of the recording, no investigation has concluded that NESO concealed evidence, operated the system unlawfully, or allowed reputational concerns to override system security. They remain allegations, not findings. A responsible engineering analysis should therefore resist both extremes. We shouldn't declare that a dangerous failure has been concealed before the evidence has been tested. But neither should we dismiss technically credible concerns simply because the final outcome was successful. Now, there is a familiar trap in risk management, and that is that the system didn't fail, therefore the system was safe. That conclusion doesn't follow. A building can survive a fire despite inadequate protection. Transformers can remain operational for years before they fail, despite being in a state of deterioration. A backup system can remain unused without anyone discovering that it shares the same vulnerability as the primary system. A successful outcome may demonstrate effective intervention and adequate remaining margin. It may also contain luck, untested assumptions, or vulnerabilities which were never called upon. The opposite's equally dangerous. An abnormal condition is not automatically evidence of impending catastrophe. That's why we need proper post-event reconstruction, not reassurance, alarm, or political storytelling. And this brings us to something which may sound almost administrative, but it's actually an engineering control, and that's record keeping. For a critical operational decision, we should be able to reconstruct the condition identified, the information available, the decision taken, the person or role exercising that authority, and the action completed. And the subsequent verification that the action was effective is very important. Live collaborative documents aren't inherently improper, but the histories must be preserved. We must be able to determine what changed, when it changed, who changed it, and whether that affected the operational decision. A resilient organization doesn't merely retain data. It preserves decision provenance. So there are now two distinctive investigation tracks. Evershed Sutherland is examining the whistleblowing allegations, including concerns about operational records and possible inappropriate influence over decision-making. Separately, Ofgem's commissioned an operational review examining exactly what happened during the June event, what actions were taken, and were they compliant with applicable rules and standards, and whether those available records are sufficient. Now, the whistleblowing investigation's governance was strengthened following concerns about its independence. Employees may approach investigators directly and confidentially. Relevant operational records, messages, and live document histories must be preserved. Oversight now includes representation from NESO's Audit and Risk Committee, Ofgem, and the government shareholders. Wider concerns relevant to energy system security need to be passed on directly onto Ofgem. And these don't prove that the original allegations are true. They just demonstrate something different, which is that a credible investigation depends upon a credible design. An investigation isn't independent merely because it's described as independent. Independence must be visible in who controls the evidence, who can speak safely, who determines the scope, and whether the organisation under examination can influence the conclusion. But Britain doesn't necessarily suffer from an absence of oversight. It has regulators, licence conditions, standards, committees, audits, and reporting requirements in spades. The deeper risk may be fragmented accountability. The regulator regulates. The operator operates. Government determines policy. Asset owners maintain equipment. Markets determine availability and price. Each participant may complete its designated process, while no one retains clear ownership over the overall system outcome. Who owns the unanswered risk when it crosses an organisational boundary? Who has authority to stop or alter an operation? And who verifies that an uncomfortable technical concern received an adequate response? They're not primarily questions of blame, they're questions of the system design, which doesn't come down to any one person. It's an organisational level process. So 5 tests appear at one time. Whatever the investigations eventually conclude, 5 principles should remain. Evidence must be recoverable. Escalation must be protected. Technical authority must be explicit. Investigations must be independent by design. And lastly, learning must be verified after the report's published, and that's a really important one. The whole purpose of this series is to try and see what we can learn from these incidents, because that's really the most valuable thing about these events. So to finish, at Bristol Airport, the backup existed, but one event affected both systems. At North Hyde, condition monitoring existed, but deterioration didn't become proportionate, verified action. And in the case of NESO, extensive oversight exists, but its real test is whether it can now produce an answer that engineers, operators, and the public can trust. In every case, the nominal control was present, and the deeper question was whether it performed its intended function under pressure. I'm not trying to decide which participant deserves the better headline. I want to know whether the questions raised receive answers that are sufficiently technical, transparent, and independent to support genuine learning. Politics may determine objectives, priorities, and acceptable trade-offs, but it cannot negotiate with physics or substitute institutional reassurance for engineering evidence. Thank you for your time today. I hope you found this video useful, and I look forward to seeing you in part 4. My name's Jason Broderick Pierce, your host for Engineering Resilience. Goodbye.